Hi, I'm Mrs. B, and welcome to Math for All, where everyone can learn more about math. I'm glad you found us because today we're going to go over something called the order of operations, which is an extremely important math concept. Please go to our website, mathforall.net, and print out the notes for this lesson so that you can follow along and have everything you need to remember for this topic. I'm going to go over the list of things to do in math in order of priority. We'll go through examples on that, then we'll discuss the special cases where there are invisible parentheses. And finally, we'll do some more advanced examples with parentheses inside parentheses. So we have this thing called the order of operations. First, let me define what math operations are. And it has nothing to do with an operation where you get surgery. Operations are the things that we do to numbers, like add, subtract, multiply, and divide. Oddly enough, we don't always do these math operations in the order like when we read a book, like just going from left to right. We get to look at big old math problems like this and make decisions on what needs to be done first based on the rules of math. And that's where this video comes in. So here's the important list that needs to be memorized. It gives you the hierarchy of which things are most important or are done first when we solve equations. The letters look like this, PEMDAS. You can remember it just as PEMDAS, or some people say, "Please excuse my dear Aunt Sally," for a fun phrase. I'll just call it PEMDAS so we don't have another saying to remember. PEMDAS should be a word in the dictionary because it is so important, but alas, it is not. I just checked. Here are your order of operations. We're going in order of what gets done first to what gets done last. First up is P for parentheses. Anything inside of these you have to do first. Parentheses is a fancy word for grouping symbols, which can look like this, forward and backward C's, or these brackets. As I mentioned, later I'll go over some places where there are invisible parentheses that you need to know about. Next up is E for exponents. Those little raised numbers, they're next up. Get it? They're up and they're next up? Sorry, math people can only try to make things funny. MD for multiplication and division. We multiply and divide anything in the order that we see it. See how M and D are on the same line? That means that they are of equal level. So you don't multiply first, you do whichever comes first as you read it, left to right. AS for addition and subtraction. The last things we do are adding and subtracting. I call them the losers because they are the lowest on the list. Once again, they are on the same line, so they are of equal importance, and we do them in order of left to right, even if the subtraction is before the addition. Let's use this recipe to look at this example to get you warmed up, to show you this new way of thinking where we have to make decisions of what to do first when we see a long math problem. 4 plus 5 times 3 equals what? Before you learn the list, you would go in a nice order like we're reading a book. 4 plus 5 equals 9, times 3 equals 27. Now we know that's not correct, so let's exit out like this to remember to not do that. Here we will do it the correct math way. 4 plus 5 times 3. We look and see what we have on our PEMDAS list and see what goes first. There are no parentheses or exponents, so next up is multiplication and division. We have this multiplication of 5 times 3, which we have to do first. I like to circle it or put a cloud around it like this to show that this is the part that is being taken care of. 5 times 3 equals 15. I write that like this. Now, best practice would be to write the rest of the equation underneath, like this. For this one, it's not really necessary, but as things get more complex, it makes it look pretty cool. Now we simplify the equation to 4 plus 15. Obviously, we do that next for an answer of 19. It definitely makes a difference which way we do the operations, since one way we got 27 and the correct way we got 19. So let's make sure we follow the PEMDAS rules to do these next ones. For these, think of them like puzzles of what to do first, next, etc. until you get an answer. Example 1, 10 plus parentheses 2 cubed minus 1 end parentheses. Going through our list, we must do the things in parentheses first. Within those parentheses, we get to go through the order of operations. Inside, I see a 2 cubed minus 1. That little 3 is an exponent, so he's the most important inside there, above the minus. Let's do a quick review on what 2 cubed is, remembering it is not 2 times 3. It is 2 times itself 3 times. 2 times 2 times 2. 2 times 2 is 4. Times 2 equals 8. I'm going to slash the 2 cubed and make it an 8 here. Next, inside the parentheses is minus 1. 8 minus 1 equals 7. I will cloud the parentheses and turn it into a 7. I will rewrite our new simplified equation underneath, 10 plus 7. We don't need to make any decisions here. 10 plus 7 equals 17 for the final answer. Example 2, 28 divided by 7 plus 3 times 7. There are no grouping symbols or exponents, so next up is multiplication and division, remembering that they are on the same level, so they just go in order from left to right. First up is 28 divided by 7. Circle it, slash it, turns into a 4. Now we have 4 plus 3 times 7. Let me rewrite that here. It is so tempting to do 4 plus 3 now. It would make this so easy, but hold steady to the rules. Next, we do 3 times 7 equals 21. Drop that down, 4 plus 21, for a final answer of 25. Great. Next example, 48 divided by 6 times 2 minus 4 plus 3 in parentheses. PEMDAS to the rescue. Parentheses first, 4 plus 3. Even though addition is the last on the things to do, the parentheses promotes him to the top dog. Circle him and make him a 7. I'll rewrite everything to watch how it simplifies down nicely. 48, 6, 2, and the 7. Next up, 48 divided by 6. Circle him because he will be simplified. Do you know this answer? 6 times 8 equals 48, so 48 divided by 6 equals 8. We're getting simpler already. 8 times 2 minus 7. Multiplication is next. 8 times 2 equals 16. Look at this. We're down to 16 minus 7 equals 9, our final answer. Let's take a break from these puzzles and learn some instances where there are invisible parentheses. You just need to know they're there. These are in 3 places you'll encounter. The most common is when we see a fraction bar with math operations on the top and or the bottom, like this one, 4 plus 10 over 3 minus 1. I like to automatically put parentheses surrounding the top and the bottom like this. It tells me to do the addition and subtraction first and then divide. 4 plus 10 equals 14 on the top. 3 minus 1 equals 2 on the bottom for 14 over 2, which means 14 divided by 2 equals 7. Done. If you haven't learned these next 2 math symbols yet, don't worry. Just write these down for future reference. The second place we have invisible grouping symbols is under a radical sign where we take a square root. It's this weird long division-like symbol like this with these points. Anything under the square root needs to be done first, like with this one, the square root of 21 minus 5. Put the parentheses inside here. Do 21 minus 5 equals 16. Now we can take the square root. What number times itself equals 16? 4 for the final answer. The last of these invisible parentheses is anything in absolute value symbols. They look like straight lines that are taller than numbers. If you don't know what they do, don't worry about it right now. A quick example will be the absolute value of -7 plus 2. There's an invisible parentheses around the -7 plus 2. We must do -7 plus 2 before we take the absolute value of it. Don't just change anything inside to positives. Poof! -7 plus 2 equals -5. The absolute value of that equals 5. Okay, you had a little break. Now we're going to step it up a notch. We'll use the same techniques, but these are a bit more complicated. First up, 11 minus bracket 56 divided by parentheses 4 squared minus 8 and parentheses and bracket. See the parentheses inside the bracket? It's called embedded grouping or parentheses inside parentheses. All you need to remember is to not panic and to work from the inside out. So we start with the inside parentheses, 4 squared minus 8. The first thing we do is 4 squared. 4 times 4 equals 16. So 4 squared is 16. Take away 8 equals 8. That parentheses turns into 8. I'll rewrite it. 11 minus 56 divided by 8. Now I'll do the 56 divided by 8 equals 7. Yay! I'm left with 11 minus 7 equals 4, my final answer. See how it looks like an upside-down pyramid with one number at the bottom? That's how these are supposed to look. Our last example will be a little bit of a challenge, but we can tackle it. Brackets, parentheses, 3 squared plus 8 times 2, and parentheses, divided by 5, and brackets, plus 4 times 3. The good news is that you don't normally have to read these things. They don't come out that great with words. Let's get started to make this monstrosity into a simpler number. Remember, we start inside and go out. The inner parentheses has 3 squared plus 8 times 2 here. I'm going to circle it and figure out what it equals. Order of operations tell me to do the exponents first, 3 squared. 3 times 3 equals 9, so that part equals 9. Plus 8 times 2. I have to multiply next. 8 times 2 equals 16. I get to do the addition to finish this parentheses up. 9 plus 16 equals 25. That inner parentheses equals 25. Now I'll copy that down. 25, 5, 4, and 3. Next, I have to do the stuff in that bracket. 25 divided by 5 equals 5. It's getting simpler already. We can do this. We can take away the bracket as it is not needed anymore. 5 plus 4 times 3. I multiply next. 4 times 3 equals 12. I'm left with 5 plus 12 equals 17, our answer. As you can see, we can now solve very complex math problems by using our order of operations, or PEMDAS, where we can figure out what to do in what order and break down long equations into simpler and simpler ones until we get a final answer at the end. Now it's time to practice what you learned. Go print out a worksheet aligned to this lesson at mathforall.net, and I'll see you next time where we will learn more about math.